All right, good morning, everybody. My name is Mr. Pham, as some of you know. I'll be conducting the lesson today on Newton's second law. And today we're going to start off with the warm-up, as usual. So how can the mass and acceleration of an object be calculated using Newton's second law? I'll go ahead and give you a couple minutes on that, and then we'll talk about it. I will take seconds just in case. Oh, sorry. Oh, yeah. All right, sounds good. I will hold down the fort. I'll give you guys another minute, and then we can talk about it. All right. So, how can the mass and acceleration of an object be calculated using Newton's second law? Any volunteers? Anybody? Do I have to pop out the sticks? Oh, yes. Okay, that's correct. But when we're looking for certain calculations, if we're not looking specifically for just force, let's say we're trying to calculate for mass, right? I'm going to write on here. Let's say we're calculating for mass, right? So how does anybody know how to calculate for mass then, if we're not specifically looking for force? Any volunteers? Do I have to use the popsicle sticks again for you to raise your hands? Okay. Elephant Eddie? Can you take a guess, and then we can talk about it? No idea? No? Okay. Okay. I won't pick on anybody else. We can just talk about it. All right, so we have to do some simple math. To calculate for mass, we have to isolate it, right? So let's say, so to isolate it, we have to divide by A over here, right? And then that gives us F over A equals M. Does that make sense? Because now for most of the problems for today, hint, hint, we give you like force and then acceleration, and that will give you mass. Or vice versa, we'll give you force and mass, and then you have to calculate for acceleration. So kind of give it away already, but so how would we calculate for acceleration then? What do we have to do? Anybody? We have to isolate it, correct? We have to isolate acceleration, A. So we just have to divide it by M again. I don't know if y'all can see the marker. It's kind of fading. Is it okay? Okay. And then that will give us F equals, or F over M will equal to A. All right? And so, I mean, we have it in the diagram at the tables over there as well. But, you know, if you need to refer back, like, you can I'll leave this up in the front here. And so that is our warm-up. And so today we're going to have a lab. No, that's the solution. And we're going to have several labs today. And how many students do we have today? 1, 2. So 5 groups of 3, I believe. So I would say it says 4 into groups of 4 here, but we can do a variation of 3 or 4. And so the first task that you all have to do today is, so for task 1A, we're going to be working with these metal cards right here. And we're going to understand how force, mass, and acceleration all relate to one another. So the lab is pretty easy. All you have to do is you have to weigh the cart and write down the data. You have to write down any of the numbers that you calculate for because they're all important, right? And then you attach these free weights to the end of this pull on the string, and then there's a pulley at the station, and then you just let it go, and the cart should shoot forward. The cart will shoot forward pretty fast, so make sure you catch it before it falls off the table and break. I did borrow all the equipment from NMSU, so you know they would like it back. And then there's an observations section. Use your vocabulary. Use words such as force, mass, and acceleration in explaining why the cart moved as fast or as slow as it did. Okay? So moving on to task 1B. It's more or less the same, but the different variation to this part of the lab is that you'll be putting these masses into the cart, right? So that should affect its speed somehow, whether it might move faster or slower. And so, again, take all the data down. It's just like 1A. Just make sure the cart doesn't fall off the table. Use your vocabulary, force, mass, and acceleration. So for task 2, we have different word problems. This is the diagram that you're going to see at the tables, okay? This diagram is really important. It's going to explain to you what you need to calculate for. Some of the word problems will give you, for instance, force and acceleration, right? So therefore, we have to calculate for mass. And so, yeah, that's for task 2. Moving on, task 3, more calculations. You'll have table problems or word problems for that one. And then task 4 is the same, more word problems. This is task 5. Task 5 is a maze, right? You have to highlight or use colored pencil or something. I want it colored, okay? And I want you guys to go through this labyrinth answering questions, okay? It's pretty. It should have more instructions on that one.
Pretty easy.
Yeah. Task 6 is the paperclip and string lab, where you have one paperclip on the table and then a string attached to it, and there's another paperclip that's off the table, right? You're going to have to take measurements on how long the string is, and also just let it go. Let the string, it should fall off the table, and you're going to see how fast or how slow it moves, and then you start adding more paper clips to it and seeing how fast it goes. Okay? And then for task 7, we're going to make a stir sheet, claim evidence and reasoning. Oh, I don't want to copy that. And you're going to pick one of the following to answer the questions, okay? And so that's it. I will be going around the stations to help everybody. If you can please get in, I think we have 16 now. Yeah, we have 16 now. So please get into groups of 4, and then, yeah, have fun. Kind of. Don't have too much fun. All right, camera, you coming with me? Oh, excuse me. I will need groups on task 6 and 1A and 1B at least. Sorry. I took the cart from here and wait. And the freeway right here. So yes, one at task 6, and then one more group at task 1B. Any volunteers before I yoink you from the table? All right, this group over here. At that table right there at the end. Please and thank you. Yep, right there. The instructions are right here. The instructions are right here.
Thank you.
Just read it. If you don't understand something, please ask questions, okay? The electric scale won't work. It will say overload. You're going to have to do it old school. Yeah.
I don't know how to do this.
Oh, I'm sorry. I'm going to put this on the side. So, for you guys, give me 1 second. So, if it's too heavy, if this side is too heavy, right, it'll go down like this. So we have to put the object on here to calculate for the weight, right? So the cart is too heavy because there's not enough weight on this side. You understand? And I'll give you a hint. It weighs somewhere around there, so you have to fiddle with these and these, okay? So for right now, while you're waiting for the scale, you can just start the experiment. So, do you have any questions on the experiment so far?
No.
You will have to add 2 variations of this weight into the cart, okay? So you can do 2 100 grams, or you can do a 200 gram, and then a 100 gram. So, up to you guys. Thank you.
No, force divided by.
So, show your work, please, and then, like, no naked numbers. It has to be the correct unit, okay? So, just letting you know ahead of time. Are you at the station? Yeah. Oh no. Oh okay. Okay. Yeah, no problem. Oh yes.
Like a one.
Okay, awesome. So this is 400 grams, right? 400, and
45.
this is off balance. It has to be on there. So it's a little bit heavier, but I'll adjust it for you. So 450, it moved. 52, you can round up. So, yep. All right, and I'll move. Oops. Can you pick that up for me?
Yeah.
Just make sure you catch the card, okay, guys? You don't have to time it. You don't have to. You can if you want. It's up to you. You can leave just the weight that's on there, or you can put more weight on it. That's why I left it in there. What's up? Oh yeah. So the reason why we're not using the electric scale is because it's too heavy. The card's too heavy, and so.
Oh, it's gonna balance out to 0.
Yeah, exactly.
I
There you
forgot
go.
about that. Yeah.
Oh, you're close. You're close. Oh yes.
Question.
Yeah.
What is the length of the string?
Forgot. Just leave it like this. That way the wheels are on the ground. Yes.
When it says length of the string and then 3 pennies, does it mean like the length of the?
No, we're just calculating for the length of the string itself, not the pennies. The 3 pennies in the it's not supposed to be pennies. It's supposed to be paper clips. I don't know why we left it on there, but it's supposed to be paper clips. But you're just calculating the length of the string and then how many paper clips are being attached onto there. So yeah, so you should have a total of 4 right there. So from 3 and then 4, you're just writing the. I have to remind myself.
What are these? Grams? Oh, 63.
So this one was still be 91. 91.
No, hell no.
So you're just making observations of how fast it goes, right? So for each paper clip.
Because it's the measurement of the string, and then we just have to measure the weight.
The mass, yeah. So go. You can use the electric scale to measure the mass of each.
Just get one and then we can just do it like that.
Yeah. So also, yeah, just make sure you take the time and yeah,
When
the
we
mass.
drop it.
Yeah, when you drop it off, just time it, see how fast it goes or how slow it goes. How are we doing over here? Good? Yes? Alright, awesome.
What is that for?
This was supposed to be like this, and you were supposed to pull it over the pulley. I'm sorry, I was supposed to come back like this, and then you're supposed to attach it, and then it's supposed to fall off. See how fast? You may want to do it just one more time with the pulley, because with the table, when it goes like this surface isn't smooth, so the friction will affect the speed of the cart. It might make it move slower. So just do it one more time and see if you can see the difference. If not, you can just continue.
We've had the 200 in red.
Okay.
Like guess it's too heavy.
Yeah.
No, we did it fine yesterday. Did you pull it through like this?
Yeah.
Yeah, it was
Like
just
that?
like that.
Yeah,
and
it
then
just
we let it go slowly.
I don't know, man. I think that 200 is too much.
No, it's not. We did this so many times yesterday, and
It
it
got worn out.
probably.
Yeah, we've only got like 2 things written down. Just put.
Well, because there can only be like a group of 4 people.
Go join any group that only has 3 people in it.
Because I was, could do, like you guys split up like 2 and 2 and then I join one of the groups.
How does it demonstrate Newton's second law?
No, go join. There's a group of 3 here. There's a group of 3 over there.
See what I'm saying? Rich and center.
Yeah, right.
The price of showing up late.
Yep.
And then
Freaking Mario, bro. It was Mario's fault.
how do you even touch it?
We can't.
It's okay, guys.
We can't take
Look,
it anywhere.
there we go. Good as new.
Hell yeah.
And if it breaks again, then I give up.
Good luck.
No, just let it down. Really slow.
Hold on. Did you purposely put that kind of weight on there?
Oh.
That's fine. Yeah. Because
Is it too much or?
it doesn't matter as long as it's weight on there.
2, 3.
Wait, do we go all the way back? Or?
You can, yeah. Just make sure you stop.
Yeah. Try one more time. To see if it's
How are we doing over here? Are we almost done?
Yeah.
Or halfway?
Yeah.
3 more? Okay. How are we doing over here? Almost done?
Yeah.
So when you get to right here, let me know. I'm gonna pull you guys off the station real quick and then pull you over here because the conclusions are just like what you observed, so you can do that at another station. Okay? How are we doing over here, guys?
70.
Yeah, oh shoot.
207?
No, 7.
There's just 70.
Oh, 70?
2, 3.
I need an eraser, bro.
Okay. So, just to move things along, you've already done it twice, right?
Yeah.
So you have what you need to do the calculations, or not the just the observations, right? Right here. And then let's just move you guys over to this station.
It's like the same way.
Yeah, pretty much. Same thing. Now, you need to weigh this cart too, because it is different.
Oh yeah, this one's way more heavier.
That's a good assumption. But just, yeah, same thing. You can add more weight onto this free weight if you want, but it's more or less the same. For task 1A though, yeah, it's just as observations. So observations again, okay?
Alright, we're done.
All right, I'll move y'all over here.
Oh, you wrote. You got the template?
Yeah.
What's up? This, yeah, it's pretty neat. It's not mine, but it follows me everywhere I go. Yeah, like I walk over here and it'll turn over here. So, okay, so just to do a quick demonstration, real quick, they're using the scale right now, but you were gonna have to measure this cart. I recommend you measure it like this, so it doesn't fall. You saw, so. There are more weights in here, but you can use a variety of weights if you want, because we're gonna have to. The teachers are gonna have to calculate it anyway. But it's gonna be like this, and just weigh it. Watch out, and just let it go. Just shoot forward. Just catch it before it. Yeah, I would catch it right here. I caught it early. I just didn't want to hit the box. But also, these weights are gonna be in here. You can pick any 2 that you would like to be in this card, okay? It can be 2 of these, it could be 1 of this, and then 1 of these. But it's up to you. And then if you have time, you can really mess with it and put like all the weights in there. But hey, it works. I like that. All right. Actually, I'm gonna put you on task 6, just because this isn't online. So if you miss this, you won't be able to complete task 6. So go ahead and hop over here. Yeah, this one right here. It's on task 6 is on table 7. It's weird. Yeah, numbers are just.
Numbers are excused. I'm gonna do this.
That way
Oh,
you
yeah.
can see the numbers.
It was going fast.
Oh yes. Oh, I'm sorry.
So for
Yes.
this, since it's giving me the force and it wants me to find a mass, do I divide these two? Would I divide or?
Yeah, you're right. Yeah. But what would you divide by?
3 divided by 6. What do you mean? I was thinking, is it like that? 3 divided by 6.
So you can refer to that diagram or what I wrote on the board over there.
Oh, okay.
So if we're calculating for, I don't want to give too much away, but if you're calculating for a certain thing, we have to divide by, we have to isolate that thing and then divide it by the force. So for example, like if we're, for the top part, if we were calculating for mass, we have to isolate mass, right? So I divided both sides by acceleration, and then we get force over acceleration equals mass.
Okay.
Yeah, there you go. Yeah, show your work. No naked numbers. You have to label the units correctly, okay?
Why is that 2? Take this big clip off so I can measure it.
You're just measuring for the length of the string, okay? And when it says pennies, it meant paper clips. So don't include the length of the paper clips.
Are we able to move to task 2 yet?
What was that?
Are we in rotation yet? Or
So
are we
you could start moving along, but make sure you use your vocabulary, okay, when you're writing these observations. This is the overall observation. These are individual observations, okay? Make sure you use the vocabulary, okay? That's what we're looking for. But yeah, you can move along to the next station if you like. Yeah.
Oh, like when you use this for the measurement? I forgot.
It's a meter stick.
What does it mean?
Oh, yeah.
That,
0 point. Okay, that counts. So,
Yeah, I'm pretty sure I timed it.
We're still doing okay over here?
Yes, sir.
Okay.
So I was like 2 kg.
2, 3. Oh, okay. Yeah, that's the one that we were talking about. They looks like the right to me. I can't give you the answer, but that looks right.
And then for Newton, what's the symbol again? Is that what symbol would I get?
It's just N
N?
for Newton's.
Oh, okay.
A capital N.
And then force, and F for force. Because it's asking how much force is in the destination or something. So when I get my answer, I think I'm getting. It's destiny. How much force it? Oh, exerting.
So
It would be F, force. Or
it would be. Force would be equal to. Give me 1 second. Let me go double check that real quick. Yes. What?
right? Can you tell us what our readings are? Because we took off and just balanced it out.
All right. So this is.
It's wrong. Oh my god.
this can't be offset. It has to be snapped in, okay? And just a little hint, this cart is heavier than the other cart. Oh wait, you haven't done the other cart yet. Cool, I gave it away. So we understand that if this is down like this side is too heavy, right? So we need to shift this somehow to where it balances out to this side. We want to hit the 0. Yeah, so I hint just move this part.
Oh.
So I think we're supposed to. What's the measure where we're dropping it? Like the.
Is your boss gonna be mad if you totally just heard me cuss on camera?
I recommend that you didn't cuss.
It kind of.
It was just this.
Somebody dropped an F-bomb yesterday and had to burn the footage.
So we measure it from here. Or we measure
So
it
no
from
You
F-bombs.
gotta burn the whole footage?
Yeah, I'm probably not going to use that footage. It was a fun class though. It's just too bad I can't use the
What
footage
period? Fourth.
first.
Oh.
We're second.
Just the measurement of the string, and you're going to time it from this distance.
So we're.
Oh, okay.
So we already have the measurement. So the measurement's just gonna.
Yes. I'll be right back. I'm coming right back for you. The answer. Give me 1 second. Give me 1 second.
Look at how cute the packaging is. I didn't even realize that. Look, $126 for the 40 ounce. Oh, that is the big one. 110.
So I can't tell you, but since this one is calculating for kg and ms, it's not force. The unit is not a force.
Okay. I'll be over.
That much I can tell you.
Yeah, I'd probably
Right.
have notes on it.
Because just try to remember from last week, when you're calculating for force, it's actually something. Yeah.
So we're trying to find the force, right? Wouldn't it be mass? To find force, is it mass times acceleration, or is it divided?
We didn't go over that, but okay. So the hint is that if we are what are we calculating for this one? Can you tell me?
Calculate the force exerted by the earth on the hammer.
So we're calculating for force, right?
Yeah.
So do we have to change the problem if we are calculating for just force? No? Yeah, you're right. And so the problem stays the same, you just plug it in. Okay? Got it? We don't have to change the problem. The problem is still the same. It's force equals mass times acceleration. Okay. That's all I can give you. I can't tell you anything else because I'm pretty much giving up the answer if I tell you any more. Everything is good over here? Yeah? Okay. Everything's still good over here?
Did you add another one? Oh.
Yeah, it's going to be fun.
Wait, let me stand up.
Yes. No, you're fine.
Here for task 4, like what exactly do we have to do?
So this, just calculate for the missing one.
You did it.
Yes. Yeah. So if you're missing, if force and acceleration is given, yep, you're calculating for mass. Okay.
I wish we did, because that would have been more
Put it in
fun.
like 8.
You really said Zoom.
That was sad. I would have thought it would have been faster.
I'm glad you are taking the time. You didn't have to for this one, but the time should help you understand if it is moving faster. No, you're fine. I'm glad that you're doing it because it'll help you understand when you write for your observation.
We scared him like, why are you adding more?
If the object that has more weight inside it is exerting more force than the sheet.
Yes. Yes. Of course. Are we ready for the guys? I'm excited for this. I'm gonna do that for like one more mass. I'm just gonna have one time. Oh. Hey, I didn't do it right. Do it again. Let's go! Wait, we have to do a second try. What?
Yes. A and B. Answer the questions below.
Stop it.
Oh, no.
Let me show you.
What happens as you add paperclips to the end of the string? Using words like force, mass, acceleration.
Okay. What? Guys, 1, 2, 3. That was fun. That was fun. That was awesome. That was fast. I didn't do it here. Oh, we can do it again.
Ready? You just copy the diagram.
Go.
But when you
Oh, that was fast, bro. We did nothing, and then we put all the magnets because my cell didn't do that.
The mass.
I will have to. Are y'all done?
The mass increases as well as the acceleration to cause
So these are the individual observations. But this is the overall observation. So you have to write what you saw. Did it move faster? Did it move slower?
Yeah, I had that written down.
And then for this one, you have to use just explain how you correlate.
Force equals mass.
I will move you to that station over there. Please, thank you. I hope you had fun with this discourse.
Very good. Very good. Very good. Very good. Oh, we gotta measure
Oh,
this.
that was the correct
And mass.
So for this one,
It's not gonna work.
you need
We need to cut it. Oh, this thing.
Is it already at the 0?
when you weigh it, make sure you just put it on that so it doesn't roll around.
Wait.
Oh, that's really bad.
You said it was less.
No, he said this one weighs more.
Oh.
You're supposed to choose one of these masses, or not masses, these weights, and put it
No, you gotta put more.
on 2 of them, any variation you want. But
Oh yeah, and then move this forward.
you can also
Go for you.
Move it.
you can put any weight, you can come out of the weight you want. And then just attach it to the string.
No,
Just like go.
I didn't say that.
I did not say that, James.
Write down the weights that you does everything, and then the whole point is to see how fast it's
Sorry, I sounded so sarcastic. I'm sorry. I didn't mean to sound like that.
151 point 57. I mean, 7.
I'm sorry, I forgot to tell you. Just if you have to point something on those, just round them.
Okay.
Yeah. The other ones are online. I did a video for these too.
That's
I
0?
recommend you get to them if you can, because my videos.
Just because you're the.
So, are y'all done with this one? Right
Yes, we
here?
just finished.
Okay. I'll put you to another station for now. Whenever y'all just grab y'all.
Now the weight.
Because y'all have never.
What was it?
Yeah. Oh, this one has a
What was the weight of the part?
I'll take it.
And then just round it to 1.
Oh, isn't it?
Double them, and then.
What was that? What? Is this? Oh. Campfire. I don't need that Mr. Reynolds. No.
You didn't follow me.
Follows you?
It's not following me. Because it's dead. The battery is dead, unfortunately. Yes. Have to readjust it manually.
Yeah, you can make that. Right? And I'm gonna buy these magnets so I can put it on the table when it falls.
These are cheap on Amazon. They're only like $12.
Yeah, he's giving me ideas. Oh no. If I show up to school with little scratches and stuff, it's because tile broke. It's because I broke it.
Why would you just let it fall on your tile?
Yeah, what the heck? Put a pillow underneath or something.
Yeah, but the stretching won't be as great, you know? Huh?
I said, are you really seeing on a people person?
Yeah.
Yeah.
Try not to move the string of bam
While climbing in the structure, a carpet dropped 576 grams per hour.
No way.
Alright, if you're done, yeah, you can move to task. Have you done this task yet?
Oh no, I'm just.
Yeah, that's fine. But if you have all the numbers down, I suggest you just use all the information anyway.
Yeah.
Are we ready?
Because
Yeah.
this is not online.
Okay, do I just let it
So
fall?
everybody needs to get to this.
What?
I just let it fall now?
Don't let us fall.
Don't, yeah, catch it please.
Yes, yes. Captain. Stay that. No, I do. When I go to there, how long? No, I know something I couldn't. Okay, you guys ready? Trust me. Oh. Okay, 1, 2, 3. That was slow.
Alright. I don't know if it's tracking. It's not tracking. Ah, this is annoying. Battery's low.
Yeah.
Let's just go.
110. I used the same amount for this for that.
So it's 110?
Yeah, 110.
What?
Yeah, 110. Yeah.
So for bucks?
Yeah. Guys, I told you.
I think we were in the right.
Using all the is better. Okay, so you know what? To this, we leave it the same, but then to trial 1, we add 200 grams. And that will go wrong with absolute work plus the extra work that we had. Yeah. The first time I used these two. Because you guys know how we did it 2 times? Yeah. I used 220s and 150. So it'd be 90.
For the
First one? Yeah.
I assume so.
No, bro, we just saw. Yeah, we just saw though.
Okay, are we done with this one? Yeah. Oh, wait. Yeah.
I say, let's take Roman.
Okay, wait, did you change?
Oh, what?
I got like in the math, but I got a 19%.
You know I have no idea. Yeah, I'm done.
So, round yeah, so most of the rounds are 1 or 2.
This is 1A. We can just
One A.
Does it matter?
Yeah, one inside of people talking to you about
I want to play with it.
15.
So we can
Do you want to both do Yeah, maybe how it is. So like in December.
Oh,
What are you talking about? Like Thanksgiving break. Or Thanksgiving break.
all done. And include all day and
I think that's like I didn't even turn on. Did you turn it up yet? This will be blurred out.
Do you know how to use those?
The electric scale won't work.
Guys, what's the question?
In your student English, you create a CER that.
I learned
Oh.
in my elementary school.
How does changing the mass of an object affect the force of that object? How does changing the acceleration of an object affect the force of it?